Okay, 2.3, solving right triangles. Okay, in this section, they talk about significant digits. Ever heard of significant digits?
Yes,
Science usually is a big significant digit thing. If I had to, I would, and I would focus, and I would learn all the rules frontwards and backwards, but I don't have to. Okay? So I'm not going to make you guys do significant digits. This is your rule of thumb. Rule of thumb. Whatever they give you, give back. Does that make sense? Whatever they give you in the problem, give it back in your answer. Unless it specifically says in your problem to 3 decimal places or whatever. Does that make sense? So if I give you to the 100th in your numbers I give you, then you give me to the 100th in your answer. I would never round an angle to the whole angle. I would always give a 10th, just because. So I would never round anything to whole numbers if you're having to round, just because it's not good practice. But anyway. Well, let's see. I got to tell you about a Ferris wheel. And this is kind of why a Ferris wheel. Okay, so this is the cover of this book. You see it? It's a wheel that turns into a Ferris wheel. Yes?
Yes.
Okay, so I love Ferris wheels, and I don't really know why. But here's this Ferris wheel. I'm going to zoom in on this Ferris wheel so you can see it. Now I'm going to read you some information about this Ferris wheel. The first Ferris wheel was designed and built by an American engineer, George W.G. Ferris, in 1893. Okay? It's 100 years before I graduated. I graduated in 1993.
That's what my mom graduated.
Okay. The diameter of the wheel was 250 feet. So it's 250 feet across. What do you know that's like 250 feet? How long is a football field?
300.
No, that's feet. 300. So it's okay. It's 50 feet less than the football field. That's wide, correct? Okay. It had 36 cars, each of which held 40 passengers. Okay, so look at this car. Like, you think, oh, that's a seat. That's not a seat. Like, 40 people are fitting in that. Let's see if I can zoom in.
It's like a tram.
Yeah. But again, what was the year? 1893.
That's insane.
Yes. Okay, the top of the wheel was 264 feet. Why is the top of the wheel 264 feet, but the diameter was only 250 feet?
Because of the stand.
Because the stand is not touching the ground, is it? Okay. It took 20 minutes to go one complete revolution. So 1893, you're in this car with 39 other people, and it takes you 20 minutes to go all the way around.
I'd be making friends.
Everybody would.
That's a long time.
As you will see in the progress through the book, trigonometric functions can be used to model the motion of the rider around the wheel. We will do a Ferris wheel problem a lot. They're one of my favorite ones to do. We're going to make triangles, and we're going to do them. And we're triangles and rectangles, and we're going to do them. But I just want to, grasp that. 1893, I'm in this car with 39 other people, and it takes me 20 minutes to go around. And it's probably, creaking and...
But that's probably cooking back then. Let's be honest.
Yeah, but there's 39 other people on that car with me. No deodorant.
Hey. You pointed at Emma.
Because Emma was...
I know.
Oh. But I don't know. I think that's cool that he had the ability to do that. But I'm thinking, let's just send 2 people around. Not... How many cars are on that? Look at how many cars are on that thing.
You said 47.
No, that's 40 passengers in each car.
How many cars are there?
Oh, there's 36 cars. Okay, so...
6 people.
What?
It's 6 people.
No, it's 40 people in each car.
No, he's being...
Oh.
1,440.
So 1,440 people Okay, average weight, 120 pounds? Maybe not back then.
Probably.
Well, but you got little kids, you got adult, you know what I mean? Like, we'll just say 120. And back then, people were lighter anyway.
Some people were fatter when they were.
No.
Or no, that's like the Victorian age. They're all
Yeah.
fat.
Well, not Victorian, but they were thinner. Okay, that's 173,000 pounds.
Jeez.
Plus the weight of the wheel itself and the car itself, and that's a lot. Like, that's trusting to get on that thing. Like, you ever think they did it at capacity? Probably not.
I bet you like when I first opened everybody was like,
Yeah, that's
"Oh,
true.
Ferris wheel."
Because, like, when we were in Boston, they were talking about the first subway, and it only went, like, 3 miles. And people stood in line for hours to get on it, go 3 miles, and come 3 miles back. So, we're going to do triangle problems. We're going to do Ferris wheel problems. If you notice in your book, they actually have an icon next to the application problems. There's so many Ferris wheel problems. Oh, Ferris wheel. It's cute. Okay, so if I give you a right triangle ABC, yeah, there's no more like definition stuff because you know everything you need. So triangle ABC. Triangle ABC. A equals 40 degrees. C equals 12 centimeters. We need to find, oh, this is a right triangle. Sorry, I didn't tell you the word right triangle because without the word right triangle, you don't know how to solve that yet. Okay, find, what do we got left to find? Little a, little b, and angle B. That looks blurry. Is it blurry? There we go. So, what is the first thing I should do?
Make it line.
Make a picture. You will notice that my right triangles typically all look the same. If you're looking at the homework I do, when I do problems for you guys, I try to change it up, but it doesn't always work for my brain. Because we don't trust our pictures, we trust our numbers and our symbols. So it's a right triangle. Does it matter where I put A, B, and C?
No.
Yeah, I mean,
Well,
depends
A
which
can't
one's
go
90.
on the 90 degree.
well, when it does A, B, C, I would assume C is always the
90.
90 degree angle, and side C would be the hypotenuse. But if they give you a picture, could they label it any way they want? Yes. And usually they'll say like C or B is the right angle or something like that. Okay. So you does it matter where I put A and B?
No.
Where do you want it? Down, bottom, top,
A at the bottom.
bottom? Next time we'll put it at the top, okay? So angle A, how do I know this is angle A?
Because it's a big A.
Yeah, because it's capital. So angle A is 40. Side A is going to be across from it. Side B is across from B. And side C is 12 centimeters. And put your centimeters on there because if you don't, guess what you'll forget to do in your answer. Put your centimeters. What was I going to say?
Well,
I don't know. If I don't label this right, am I going to get right answers? Mm. Okay, what do you want to find first?
angle B.
Angle B, why?
Because it'll be the easiest.
This is the easiest, right? So angle B, I'm going to just show a little bit of work. I'm going to take 90 minus 40. Aren't you?
Minus?
Yeah. Because what did A plus B have to equal? 90. So I could take 90 plus 40 minus 180, but why would I do that? But why? Do you know A and B have to have a sum of 90?
Yeah.
Yeah. So just make it easy on yourself. So 90 minus 40 is 50. And don't forget your degree. You know where people lose most of their points on a test?
Labeling.
Labels. Okay. Now what? And we got A and B. Which one do you want to find? A. Okay. Well, A is opposite angle A. So I want A, and I have the hypotenuse. So what's opposite and hypotenuse? Sine. So the sine of 40 equals A over 12. So A equals what? I don't want the number, I want the equation. Or what you plug in a calculator. What math would I do for solve for A?
Sine of 40 or 12. Or no, 12 sine of 40.
12 sine of 40. Okay, I'm going to put that in the calculator when we're done. Okay, now we have to find what? B. And I'm going to tell you guys, rule of thumb, you use what you're given, not what you find. Got it? If you have to use something you find, then you have to use it. But why would it be a good idea to always use what you're given, not what you find?
Because what you're given is 100% right.
Right. What you're given is 100% right, and what I find may not be. Okay, so you notice I'm not going to write any answers on here. I didn't write 50 degrees on my picture, did I? No. I would only write it on there if I had to use it to find something else, which sometimes we do. Okay, so now we want B. So B is the what to 40? Adjacent. B is adjacent to 40, and I have the hypotenuse, so I'm going to use what? Cosine. So cosine of 40 equals B over 12. So B equals what? 12 cosine of 40. And if you put those in your calculator,
I'll do the cosine.
I think it tells you two significant digits, and I think the reason why they say two significant digits is because 12 is two significant digits. Does that make sense? Like the number 12 is two significant digits, so they...
Do I have to take it out of degrees?
No, you're putting in degrees. You need to be in degrees.
Or I got like a decimal.
So A, you should get approximately 7.7 centimeters.
Why? How? What did you do that I didn't?
Well, 12 sine of 40. All right, you're not in degrees, you're in radians, I bet. Go to your mode. Because you're using the one that looks like exactly the graphing calculator, aren't you?
Mm-hmm.
Okay. Everyone else gets 7.7. And then B,
You get approximately 9.2.
yep. And please use your approximately's. The book doesn't, and I don't know why, but I do. And if you don't, I will take off for that as well. And centimeters. I think it's deceiving not to use approximately's because you can get decimal answers and they can be exact, correct?
Mm-hmm.
Okay, now in here they show you could use this, but I also could use Pythagorean theorem, but if I used Pythagorean theorem, I would be using what I found, wouldn't I?
Yeah.
Yep. And then you would be rounding something and then using it again to round something else. And in here, it doesn't make a difference. You still get 9.2. But if I were doing something that had to be really, really precise, and I did that, if I used a rounded answer to plug it in to rounded answer again, would that be a good idea?
No.
No. And we have calculators, right, that we can put whole big things in. We have computers that will do calculations for us. When we're taking the time to do calculations like this, should we take the time to get the most exact answer that we can get?
Yes.
Yes. Now, if I had to do a slide ruler and everything else, I might be rounding and rounding and rounding, but not here. Okay. So, do we need another one?
Sure.
Okay. Oh, actually, this
This
time
is all we're doing.
you're solving right triangles.
So basically.
I mean, other than like having to read stuff. Okay, in a right triangle again. ABC. A equals 2.73, and they aren't giving me any units this time, so do I have to give any units back?
Little a.
Little a. Little b, or how about I say side instead of little? That sounds...
I like little.
So, side A is 2.73, side B is 3.41. I absolutely hate this problem. Because I don't want to say 3.41, I want to say 3. What? 14. Find the remaining sides and the angles. So find everything else. Find it all. Honestly, guys, if I had a problem, even if it told me to find one thing, I'd find it all anyway. Okay. So, first thing I do is draw a picture and label it. And this time we're going to put A up on top and B on the bottom, just so you don't get too comfortable. And so side A, I got 2.7. Does it matter if you draw your picture that looks like mine or not?
Yes.
No.
Yes.
No.
Yes.
As long as you are labeled correctly. I hate little C's.
I hate big C's.
Oh, they look the same.
I know. But the little C's are a little bit of
Sometimes.
I know, big C's are. You just have to.
Okay, so what do I do first? What do you want to do?
Probably find C. Like little C.
Okay, side C. How are you going to find side C?
Diagonal.
Good job. So that's going to be what? C is going to equal the square root.
2.72 plus.
Don't forget to square it.
Yeah.
Okay. Now, am I going to do any of this by hand?
No.
No. Now, if that was 6 and 4, would I do it by hand?
Yeah.
Yes. So, all at one time, no piecing. So, what are you going to put it first? Square root, right? No,
Yes.
you don't have to.
I'm done.
Okay. And then plus 3.41. Should get approximately 4.37. Everyone get 4.37? Okay. Okay, now what? Well, what's all include?
The angles.
Angles. So how do we find angles? What do we have to use to find angles? You did it yesterday. Well, you sine, cosine, tangent.
Yeah.
But what of it? The inverse, right? Okay, so when I find an angle, I have to use the inverse function, yes? Okay, so what I was given was side A and side B. So that's what I'm going to be using is side A and side B. So I guess we'll just find angle A just because angle A is first. Okay, so angle A equals, and I can put equals here because it's just going to be the formula that I'm using, right? Or the equation, not the formula, sorry. So I have the opposite and the adjacent of angle A. So what function is opposite and adjacent? Okay, so I'm going to do inverse tangent. And guys, I don't think I actually ever said the words, but I've never given you. When you do sine, cosine, and tangent, those are lowercase letters. If you are using uppercase letters, you are meaning something completely different. So you cannot use an uppercase T.
What does it mean?
It means you're using a restricted domain, which we will go over in chapter 3. And we aren't using restricted domains, and so you can't use it. Okay.
Anyways.
Okay. So, well, restricted means too small.
Right.
Domain is the X's.
Right.
You know what that means. Okay, opposite is what?
The opposite of A?
Mm-hmm.
2.73.
2.73. The adjacent is 3.41.
Was it?
Okay, Now, personally, I don't put this in my calculator. I set up everything for a problem and then I use my calculator. That also stops me from using what I find. Okay? So then angle B. So I have now angle B. What do I have of angle B? Opposite and the adjacent. So what function are we going to use? Okay, so inverse tangent because we're finding a what? Angle. Opposite is 3.41. Adjacent is 2.73. So angle A is approximately what?
Approximately 38.6 or 38.68.
So 6.8 would give you 7.
Yeah.
It would give you that number that I can't say, but pointing to. Words have been hard. Words have been hard. I'm hoping that your work is looking kind of as neat as that.
Wait.
Yeah.
Okay.
Where'd you get that?
Inverse tangent.
Yes.
Which one, B or A?
Hey. Or B.
Inverse tangent.
Yes.
And then 2.73 divided by 3.41.
Do you not have to put the 1 in there?
What one?
What we were doing yesterday.
You push the inverse tangent button
Yeah.
right here, and it puts it there.
He's putting it over one.
Yeah.
No, we're not doing a reciprocal identity. We're not doing secant, cosecant, or cotangent.
Okay.
You had to do that because the things you were doing are on the calculator. That seemed kind of a silly question. Seemed like a silly question.
Dang, she's dissing.
Okay, now did everyone get 38.7 and 51.3?
Yeah. I think I'm good. I don't know about you guys.
I haven't done the 58.2. What are you talking
51.3.
about? Oh, there's just 58.2.
No,
No?
that's 38. Okay, so the circle in figure 3, which you don't know what it looks like, has a center of C and a radius of 18. If the triangle ADC is a right triangle and A is 35 degrees, find X, the distance from A to B. Okay, you can't draw a picture like that, but you can look at figure 3. Figure 3 is a circle. You guys drawing circles as good as I am yet?
No.
Better
Absolutely
than
not.
I don't know how I draw circles that well, but I do. Okay, so you have a circle,
Yeah.
and you go down here, straight down, straight over. Have you seen this picture before?
Looks like a lot. Yeah.
Yep. So this is a right triangle. We have A, and this is the opposite direction of the book, but that's okay. D. This is B.
Little C?
No, that's an angle. C.
So big C?
Yeah. It's written on an angle. Let me make it bigger for you.
Thank you.
Okay. And it told me angle A was 35. And it told me the radius was 18. So where's the radius go?
And where C is?
Well, it actually goes here and where?
There.
There? Yes?
Where's the radius?
A is 35?
Yes. What did you ask, Alex?
Radius is 18.
Yes, radius is 18. Okay, have you done a problem with this picture?
No.
Yeah.
Yes.
When?
Well, chapter 1, section 1.
Oh, yeah. Oh, I don't remember talking.
Okay, so there's our picture. It says find X. Oh, X is here. X is AB. They've got that in red. I don't got it in red. That right there. Okay. So what do you want to do? Do we need to find angle C?
No, no, we're just gonna find out.
We don't need angle C.
We just need to find x.
We just need to find x. Now, if that 18 wasn't there and I just did this, and I told you to find x, what would you do?
Or you can 90 degree. Right triangle.
Yeah.
You have a right triangle, right? And you would use sine, cosine, or tangent?
Yep.
Okay, so it doesn't matter. Don't get confused that we have 18 and x in a side because that side is 18 plus x, is it not? We're just going to use 18 plus x and do the math that we have to do. Okay, so don't get caught up in the picture. Look at it and say, well, I got to use sine, cosine, and tangent. Which one can I use? What parts of that triangle do I have?
You have the part of the hypotenuse.
We have
The hypotenuse and the what of A?
side.
Adjacent. No, opposite.
Opposite of A. We have the hypotenuse and the opposite of A. Yes?
I basically said that.
Yeah, you were trying to. Words were hard again. So what function is that?
What did you say?
The hypotenuse and opposite.
It's side.
It's sine.
It is not.
Sine's opposite. Okay, so we have the sine of 35 is going to equal the opposite, which is
18.
18, over the hypotenuse, which is
18 plus 6.
18 plus x. And we probably should put parentheses around that 18 plus x so we remember that is one thing and I'm going to be moving it around, right? Okay, so this is it. You will have this kind of problem over and over and over and over again.
Do you have to solve that?
Yes. You multiply, you distribute, you subtract, you divide every single time. Multiply, distribute, subtract, divide. Multiply, distribute, subtract, divide. I can tell you that because I've done that problem so many times. So what I want you to do you know how to multiply?
Yes.
Do you know how to distribute?
Yes.
Do you know how to subtract?
Yes.
Do you know how to divide?
No.
So should you be able to do this problem?
No.
It's follow the steps. Do not get caught up that one on my side is 18 plus x. Don't get caught up in that. Just do the math. Got it? So if I have a fraction, the first thing I want to do is don't have a fraction anymore, yes? So I multiply by the denominator.
To the other side.
Yes. So the first step I said was multiply, right?
Yes.
So I will have sine of 35, and here I would make sure I'm putting my 35, times 18 plus x, and your parentheses have to be there because that is a quantity. Yes?
Does it matter if it's in front?
No, it does not matter if it's in front.
Okay. I put it in.
Okay. So now, what does the math tell me I have to do?
Divide by. No. What? No, no.
Get x alone.
You got to get x alone. What's my problem with getting x alone right now?
It's attached.
That is.
It's attached to the 18, so how do I unattach it to the 18?
Divide it by 18. Distribute.
I distribute. Remember I said multiply, distribute? Because I've got to get this out of this quantity, and the only way I can do it is to do the math before it, right? So I'm going to get 18 sine of 35 plus x sine of 35. Everyone following? So I told you multiply, distribute, subtract, or it could be add if it was negative, right? And then divide. That's what I said. And that is every single one of these problems like this, guys. Multiply, distribute, subtract, divide. Every single one. So have we multiplied?
Yes.
Did we distribute?
Yes.
Now, I'm solving for x, so I need to move everything else over, right? So then I would subtract that, because there's no x, correct? So I have x sine of 35 equals 18 minus 18 sine of 35. It's not that bad. It looks bad because we have a lot of stuff we're moving, yes? But is it that bad? Okay, now I want x by itself, but this is x times the sine of 35, so I now have to do what? Divide. Did I multiply, distribute, subtract, divide? Yes. So divide. So x equals 18 minus 18 sine of 35. And if you need to, put parentheses around the whole thing because that is a quantity, yes. Divided by the sine of 35. Now, in the past, people will go, oh, we can factor out an 18. Could you factor out an 18 of that numerator? Yeah. Because they both have 18, yes? I would only do that if this had something like that to reduce. Is there anything to reduce? No, so there's no point of doing it. Just because you can do it, we shouldn't always do it, should we? So we now are going to put this in our calculator all at one time. Did you hear me?
Yes.
In pieces? No, all at one time. So we have to put parentheses on the numerator here. Have to. And if you put them on your paper, will you remember to put them in your calculator?
Yeah.
Yes. So parentheses, 18 minus 18 sine of 35, parenthesis, divided by. Now you do not have to put parentheses around the denominator because it's only one thing. But you could just because then you would always do it because sometimes you have to. So that's up to you.
Is it one decimal place?
Sure. So x is approximately, and actually they didn't give any decimal places because in the problem they gave you 18. But if you're rounding, to me, like you always should give at least one. I am not going to count off unless I say round to the nearest tenth and you go to the 100th, I will not take off. Okay. So 13, approximately 13.4.
Yeah.
And do we have inches, centimeters?
No.
Inches. I didn't put it on there, but it did have inches, sorry. Okay, you will have these problems. So when we first drew this picture and I asked what should we do, be honest with yourself. What was throwing you off? The circle? Didn't know where to start? Okay, was the 18 and the x, like, did your brain not want to deal with both of those together? Kind of. Could I have just changed this and said, like, y? Yeah? And that would have been great until I got here where I had to distribute. Right? So this is one thing. It's stuck together. It's one thing until I distributed it and made it what? 2. Now, I'm going to tell you right now, I can do these till I'm blue in my face with you here in class, and guess how well you'll do them on a test if you never do them alone. You'll never do them. You have to do them at home alone. Now, if you start doing them and you screw them all up, we can fix that in class. But you will not learn how to do these problems if you just watch me do it. Am I clear on that, guys?
Yeah.
It won't happen. And they're not that bad. I could tell you what was going to happen before I even did it. And I knew it's because of this right here.
My brain wanted to use Pythagorean theorem. But I couldn't because...
Yeah, you don't have another side. If I had another side, could I do Pythagorean theorem?
Yeah.
Yeah. And I just would have to do that x, or that 18 plus x, and I would have to square that quantity correctly.
I know how to do it.
I know you know how to do it, but you choose not to sometimes. Okay, I got one more. Actually, I got more than one more. I'm doing all these examples because I want you to see them before you have to, like, use them. Does that make sense? Hopefully we have time to get to the Ferris wheel example. If not, we'll have to do it Monday.
We could just...
Monday. Oh yeah, it's last week or last week. Why would we do it Monday?
Well, because you have to learn how to do them.
Oh yeah.
Okay, so I'm drawing this picture. This would be in the book, and if it's in the book and you're doing a problem with it, should you be drawing it on your piece of paper? Yes. Okay, have you ever learned about, like, tactile learners? Like, I'm a visual learner, like a tactile learner, I need to touch things. Okay, in math, you can't touch things. But can I draw a picture and manipulate it? Yes. So that's like the making it real to yourself. Okay, so then I have 38. If you ask me to do a problem, even if you have a picture, I usually go and rebuild the picture because it means more to my brain for some reason. Okay, then it tells me A to D is 32. I want to find X, and I have H. Okay, so I want to find X. And it tells me to find X. That's just what it tells me to do, is find X. Okay, this is similar to the last problem, but a little different.
Why is that H on that side? Isn't that hypotenuse?
Well, it's height.
Oh, okay.
They named it H because it's height.
I see.
Okay? How many right triangles do you see in that picture? 2. Now, you had a picture kind of like this on your test, yes?
Mm-hmm.
And a couple of you tried to use the Pythagorean theorem on this triangle. What's wrong with that?
It's not right.
It's not a right triangle. But can I use it on this triangle?
Yeah.
Can I use it on the big triangle?
Yeah.
So should I probably... well, I don't have enough to do Pythagorean theorem. So if I don't have enough to do Pythagorean theorem, I have to do what? Sine, cosine, and tangent. So we're going to set this one up. We won't get through it, but we're going to set it up. Okay, so I always like to start with like the little one, just because it's there. Cover it up. Look, covered that up. So I have, and H is in both triangles, correct? Okay, so that's a good thing. Okay, so what would this be? I've got this angle, and X and H are the what? What and what of it? That angle of 54. Opposite and adjacent. So what function?
Tangent.
Tangent. So I have tangent of 54 degrees equals H over X. Thank you. Okay. So I'm going to leave that equation alone, and I'm going to move next to it. Now I have the big triangle. So I have 38, I have the opposite, and I have information on the adjacent. Yes?
Yeah.
Okay, so the adjacent is not 32, it is what?
32 plus X.
It is 32 plus X. Okay, so what do I got there? What function?
Sine.
Still.
Opposite and adjacent?
It's still.
Tangent.
Still tangent. So tangent of 38 equals H over 32 plus X. Okay, so I have 2 equations. How many variables do I have? 2. So do I have enough information then? If I have 2 equations, I have 2 variables, I can find what I need, yes? So if I need X, I don't want to eliminate X, I want to eliminate what? H. So if I solved this for H, and then I plugged it in here, should I be able to solve for X?
Yes.
Yes. So let's solve this for H and plug it in real quick, and then we'll call it good for the day.
H equals X tangent of 54.
So H would equal X tangent of 54. So then when I plug this over here, I have tangent of 38 degrees equals, what's H now? X tangent of 54 divided by 32 plus X, and put those parentheses around this. The numerator I don't have to because it's multiplication, correct? But the denominator is addition, and I need to remember that. Okay, so that's all the further, but are we going to multiply, distribute, subtract, and we're going to add factor back into it because we're going to have X's on both sides. But on your assignment, you have your assignment. It's 1 through 25 odd. Actually, let me just look how far that took you. I might not even have needed to go as far as I did. Okay, everything there, we could have stopped after like the 3rd example. Everything there we've done already, okay? We will pick up here. Don't lose this. We will pick up here on Monday after we answer questions. Got it? If you want to keep going, I think Monday's assignment's on there, and we did get several of those. You can. But the 1 through 25 odd are mostly just here's a triangle, solve it. Okay? I tried